Here the given question is a parallel plate capacitor of capacitance 20 microfarad is being charged. Actually, it's not millifarad. Here we have to make the some correction. It will be microfarad mu. So microfarad being charged by a voltage source whose potential is changing at a rate 3 volt per second. The conduction current through the connecting wires and then displacement current through the plates of the capacitor, what would be? This is the question we are going to discuss now. Here it is given the parallel plate capacitor. So we have to draw the capacitor. This is a hypothetical diagram, conceptual diagram for the capacitor. The capacitance it is given, the current is actually it's going. This is a conduction current in the wire. Here also it is IC. Suppose if you are connected with the external battery, the being charged by the voltage source whose potential is changing at the rate 3 volt per second. Here the potential is changing, it's a varying potential. So it is given the first quantity, the potential is changing 3 volt per second. The next one, the capacitance of the capacitor, it is given the C value. C usually represents the capacitance of the capacitor, 20 microfarad, or you can say 20 into micro represents, micro is equal to 10 power minus 6. So farad. Then being charged by the voltage, these two things is given. Then they are asking what is the conduction current through the connecting wire and then displacement current through the plates of the capacitor. What is the conduction current? What is the displacement current? These are the two quantity they are asking. That is a good question. Here conduction current we know, it is conduction current means it's need the physical wire. So here these are the wires, that means it's need the conductor. There is a electron, it will carry the current. Here also the electron, it will carry the current. What is a displacement current means? Suppose if you are charging this capacitor, the positive charge accumulate here because it's connected to the positive terminal of the battery. The negative charge is accumulated here because it's connected to the negative terminal of the battery. If one side of the plate carry positive charge, another side of the plates carry the negative charge, there is an electric field in between the capacitor. Due to this electric field, because there is no conductor between these two, it's a free space, or either it will be filled by the dielectric, but now we are consider in between the capacitor there is nothing, there is a vacuum. So in this vacuum there is an electric field. Due to that electric field there is a displacement current. In general the displacement current we can call D equal to the permittivity of the free space time, the electric field, because here there is no material. If we have the material, then it will be the permittivity of the medium times the electric field. That is a displacement current. So here actually I put ID, so here we can call it's ID. So that means whatever the current IC passing through the connecting wires, then the displacement current also will be same amount. So first conclusion we can make, because here if it is 4 ampere, here 4 ampere, in between it can't be possible 3 ampere. The displacement current also have the 4 ampere. So that much amount of electric field will be there. So first conclusion we can make, the conduction current is equal to the displacement current. This is the first conclusion. So once if you find the conduction current, then it will be easy to tell what is the displacement current. Now what we can do, first we can write the relation between the voltage as well as the charge in the capacitor. We can conclude the charge is proportional to the voltage. As the charge increases, voltage increases, or you can make this as put the proportionality into equal to by adding one constant. You can convert this proportionality into equal. That constant is equal to the capacitance of the capacitor. So C times V. This is a relation between the charge as well as the voltage in the capacitor. As the charge increases, then voltage will be increases. The voltage drop between the capacitor will increases. This is the relations. So what we can do, we know the voltage variation. That means the dV by dt, here I put only V, it is actually not dV by dt. So just a small correction, it's 3 volt per second, because the unit itself represents voltage per second. So then the dV by dt is given. So if you want to convert this equation in terms of dV by dt, then you need to take the derivative on the both side with respect to time. So if you are taking the, so take differentiation or derivative with respect to time. Once if you are taking only, then we know left hand side it's dq by dt, that will be represent the current. Right hand side dv by dt, that represents the voltage changes it is given. So if you are taking the left hand side, it is dq by dt. Capacitance of the capacitor is constant. It is the properties of the capacitor that will be constants. So we can't take the derivative. If you are taking the derivative of voltage, it's a dV by dt. So through the physical wire, dq by dt, through the physical wire we can call, because the rate of change of charge carrier, it will be current. So through the wire you can call it's a conduction current. IC equal to dq by dt, the capacitor time, capacitance time dV by dt. We know what is the capacitance, we know what is the dV by dt. Hence IC equal to capacitance, it is given 20 microfarad. So 20 into 10 power minus 6, this is the capacitance. dV by dt, it is given, that variation is equal to 3 volt per second. This is it is given. So now it is after that it will be simple calculation. What we can do, just you can multiply with this 3, the conduction current equal to 320 into 10 power minus 6. Current in general it is represented by the ampere. So IC equal to, you can call 60 into 10 power minus 6 ampere, or the 10 power minus 6 we know it is micro ampere. So the conduction current, the amount of current passing through the wire, it is 60 microampere. Then we can conclude the displacement current, that is also equal to 60 microampere, because both of them are equal. So the displacement current also equal to 60 microampere. This is a conclusion we can make for the given problem. So just you can take the notes. From the above discussion, we got the option, the conduction current as well as the displacement current both are equal to the 60 microampere. Here it's a micro. So this option B is the right answer.